Hello, a quick demo video of Yasha Baby's tank controller. And here's a quick peek at Yasha Baby herself. Yasha, she's asleep on her basking spot, very cute. This is the reason we do the work. Yeah, so jumping into it, I wanted to give an overview because it's kind of hard to piece everything together over the diagrams and the photos. So really, the goal was to have a web page so I can dynamically control stuff remotely and from my phone. Currently, I need to manually flip these switches, or there's also a timer-based device that I plug the lights into, and it'll turn on at the same time every day and turn off at the same time every day. But I wanted a little bit more control than that, and there was nothing really cheap enough and performant enough for what I wanted to do. So I'm deciding to create this system and include all the features that I would have wanted from something on the market. So here is the first prototype. We have heat lamp control and light control, and that's generic for any device you want to control, and it's controlled based on things like time or temperature. And the temperature is obtained from sensors that I have integrated to my main board. So let's switch over to the boards themselves. We have two ESP32 boards, but one of them is running all of the devices and sensors, and the other one is purely responsible for the camera feed. And it's the ESP32 cam board, and it has the camera integrated into it, which is great. Very cheap and very performant. Very great for this project. So these two blue boxes are relays, and these let me control the light and heat lamp based on digital signals sent from this. So this board can process the sensor data and use that to turn the devices on or off, or know about what time of day it is. And what's providing these sensor updates below are these sensors. So first we have just a humidity and temperature sensor for the cool side of the tank. It provides this bottom row of information. And then this is a cool sensor. It's a IR contactless heat sensor for temperature readings. And it's the same principle that the COVID temperature guns use to measure your forehead temp. And so I'll put this against my forehead and you'll see the temp go up. That's a classic. And this will sit above Yasha's basking spot. This will sit up here pointing down on the rock and measure the temperature to make sure it's at the right heat. So that's really cool. That's what these devices are doing. And then this camera board is responsible for the stream, and I did want to quickly highlight the architecture choices here. So I wanted this board to run as quickly as possible and just focus on taking pictures and sending them to my web server running the video. So, and I also wanted it to be configurable and controllable from the web page, and I didn't want it to be running a Firebase client to read data from the database. So this is under the hood, the database that's managing everything. You can see the sensor updates are coming in. We got status with the time. This is where I set the tank name. Also, we have so the devices themselves are, when I press these buttons, it updates the desired state of the devices. And I didn't want the camera to have to run anything that's processing this database. So all that processing of the database is happening here. And I set up an ESP Now connection between these two boards. So that's a little bit more complexity, but it's worth it for the performance benefit. So these two are talking over Wi-Fi to start and stop the stream. And this board is talking to a video web server running on my laptop. And I'm really happy with how this turned out. So this is the video web server. It's not running anything right now since the stream is inactive. But this is mirroring my local host traffic, which is on my computer. I protected the stream with authentication so you can't see it. But this is the URL on my laptop hosting it. And I have a Cloudflare tunnel that's mirroring that traffic to the open web. So if I pull up this website, you'll see the same thing as it's on my local host. And this doesn't incur any risk on my laptop here, so it doesn't have to be exposed to hackers. I rely on Cloudflare for their tunneling service. It's great. No ad here. So yeah, it's all connected, and we'll start the stream at a high FPS. So the stream got triggered here, and you'll see. Let me pull up the logs from. On the right, we have the main board. So this main board, it sent the ESP-NOW packet, and on the left, you can see that it received the ESP-NOW packet and it's running at 30 FPS, and it's quite performant. I'm happy. This is like 5-second delay. You can see, I just got my finger there and I'm wiggling it. And this board, mind you, was $7, and it's running a pretty high performance stream. I'm thrilled. So yeah.